Hello, welcome back to Math 110. We're going to cover lesson 1.3 today. Let's get started with our prep skills. Skill number one is recognize multiplication as repeated addition. We remember that from grade school. So 7 plus 7 plus 7 plus 7 plus 7 is the same thing as 5 times 7. I had 1, 2, 3, 4, 5 of those. So 5 times 7, and we knew our multiplication table, 35. If I'm doing signed arithmetic, -4 plus -4 plus -4 plus -4, there are four of those. They're the same thing. -4, 4 times -4 is equal to -16. The very same thing if I did -4 minus 4 is -8, plus -4 is -12, -4 is -16. So our skill 2 is compute percentage of a whole. To compute a percentage of a whole, compute the given percentage from decimal form by moving the decimal 2 places to the left. Then multiply that decimal by the whole amount. So if I had the 40%, I want that decimal number. I'm changing the 40% to 0.40, and then I'm multiplying it times that whole number, which is 100. That'll give me the 40. So 40% of 100 is 40. 5% of 30, 0.05. I move my decimal 2 places to the left. I multiply it times 30, and I get the 1.5. So the calculator will do that nicely. Excel will do that as well. So here's some prep skills questions, and we'll use Excel to handle this. So write each repeated addition as multiplication and find the result. So I have 1, 2, 3, 4, 5, 6. So I'm going to escape out of here, and I have my Excel ready in the background. I'm going to open that up. And that was 6 times 10. So I'm just going to, in my cell, I'm going to go equals 6 times 10. And it'll do that calculation for me as 60. So -3 plus -3 plus -3 plus -3 plus -3, that's going to be equal to 5 times -3. And I want to put a parentheses around here so that Excel will understand that that negative goes with that. And that gives me a -15. Finally, we're going to do our percentages of whole numbers. First, I'm going to do the 50% of 84 equals 0.5. That's our 50% times our 84. That would be 42. 35% of 200. The 0.35 is our decimal of 35% times the 200. So 70 would be 35%. 4% of 1,000 equals 0.044% times our 1,000. And that would be our 40. Be the answer. And then finally, 11.3% of 550 equals 11.3.113 times, and that number was 550, 62.15. Let's check and see if we need more decimals. In this case, I moved it over, and if there was more decimals, there may have been a number in the thousandths or the 10,000ths, and that would have showed up in there. So you can reduce that back down to that. So lesson 1.3 is about accumulation. Our learning objectives interpret multiplication as repeated addition. We've kind of covered that as our skills. And then multiply or divide quantities. So for our classwork, questions 1 through 5 use the pie charts below. The first illustrates the percentage of energy consumption in the United States by energy source for 2014. The second illustrates the specific breakdown of different renewable energy sources. So here's the consumption by source. So petroleum would be 35%, natural gas 28%, coal 16%. And this is our breakdown of renewable energy sources. So here we're going to have to go to the colors for our wind. That looks like 18%. Our biomass waste, 5%. Our biofuels, our wood, our hydroelectric, our solar, and then our geothermal. So if we have these percentages, then we can go back and calculate, put me up here, we can calculate if we're given the whole number, what the proportion would be. So the first chart shows that 35% of our energy source came from petroleum. The total energy usage for the United States in 2014 was 98.3 quadrillion BTUs. What does the result of the calculation 0.35 times 98.3 tell us about energy usage? Include the result of that calculation in your answer. So 0.35 times 98.3 is 34.045 quadrillion BTUs generated by petroleum in 2014. Does the calculation 98.3 times 35 have the same result? So if I just did this and switched these numbers, which one comes first? Well, it doesn't matter in multiplication. Multiplication commutes. So 3 times 4 is 12 is the same thing as 4 times 3. So in this case, we would get the same answer, 34.405. How many quadrillion BTUs were generated using renewable energy sources? So here's our renewable energy sources. There's with 10%. So 0.10 times 98.3, the 9.83 quadrillion BTUs. How much of that energy was generated using wind power and then solar power? Well, here was our breakdown of renewable energy sources. Our wind was 18%. 18% times the 9.83, the 1.77. So we're using the 9.83. That was our percentage of the whole based on renewable energies. And now we can break down those renewable energies using this. So that 9.83, 1.7 quadrillion BTUs were for wind. And here's our 4%. They were asking for solar. There's our solar, 4%. 0.04 times 9.83 is 0.39 quadrillion BTUs. Back to the first pie chart, looking at the natural gas slice, what is the significance of the calculation 100.8 divided by 360? So that would be the number of degrees for the natural gas slice in the pie chart. So if I did that percentage, 0.28 times 360, that would be the 108. We've looked at that. Does the calculation 360 divided by 108 have the same result? If I did this division, I get 3.57, and that basically tells us that order makes a difference. If I flip these things, 2 divided by 4 is a half, but 4 divided by 2 is 2. It's not going to be the same thing. So we're going to get these a lot in word problems. They're just descriptive phrases. You just have to pick out what they mean. The product in 20 times in 250. So if I want to know what the product of 20 and 250 was, I'm going to be doing the multiplication. So product is the same thing as multiplying 20 times 250. That would be $50. Last year I made 2,000 working part-time, but this year I made 3 times as much. So times is multiplication again, another word for multiplication. 2,000 times 3, that would be $6,000. And then the quotient of $24.12 gallons. The quotient of 24 on top and 12, there's the division. So the quotient gives us the same thing as division. That's going to be $2 per gallon. And that closes us up for this lesson. We'll continue this along next time. See you then.